Okay, so up to this point, we have looked at friction in the horizontal direction, typically being force applied and force of friction. And we've also looked at forces in the vertical direction, typically being force normal and force of gravity. We've also learned that force normal we can equate with force tension. It's also equated with the word force applied. But what is consistent regardless of the words that we're using is that there is a force and an opposing force in the horizontal direction, and there is a force and an opposing force in the vertical direction. And in this particular lesson, we're going to focus on the force of friction, because within that force, there are two types of friction that we deal with. We deal with static friction and kinetic friction. And those two words are giant clues into what those types of friction are. Static has the root in it that has the same root that we find in the word stationary. And so static friction is when it's the minimum amount of friction needed to prevent objects from moving. So if we were to look at this paper, there is a minimum amount of force that I need to apply, and it's not very much, but to get this paper moving. There has to be some. And so what's happening is I'm applying a force to the paper in this direction, and the table is applying a force in the opposite direction against the paper. So I'm applying a force this way, and the table is applying a force this way. And so it's the minimum amount of friction needed that the table needs to not let this paper move. Okay? Kinetic friction, and we've looked at kinetic energy and we looked at kinematics, and we know that it's the study of motion. So kinetic friction are for objects that are in motion. And when we look at static friction and kinetic friction, there is a relationship between the two, and we call that the coefficient of friction. And it's the ratio of the friction force and the normal force between the surfaces of two objects in contact with each other. When we look at a diagram, we're like, how can that be? Right? In a free body diagram, if this is the direction of motion this way, in a free body diagram, force of friction would be in the opposite direction of motion. And we know that force normal is 90 degrees to the direction of motion. And so we're looking at this and we're like, well, how can this be? Because these aren't opposing forces. The opposing force of friction is force applied, and the opposing force of force normal is force gravity. So what's going on here? And so what happens is it looks at the friction, looks at the nature of the surfaces in contact with each other. And so static friction represents, so this symbol, this U with the tick out the front, we call that mu. And it has this subscript of S, and that's the static coefficient of friction. And that is the conditions just before it starts to move. It's the threshold. It's the bare minimum amount that it takes to move this paper. Okay? The coefficient of kinetic energy, so again, you can see this U with a K beside it, this being kinetic, is usually smaller than the coefficient of static friction. So why would this value here, which is about objects in motion, And this one here is about stationary objects. Okay, why would this one here be smaller? Why would this one here be smaller than this one? Well, let's look at Newton's first law. Newton's first law states that once an object is in motion, it wants to stay in motion. Okay, and so that means that it takes quite a bit to get it going, but then once it's going, it doesn't require a whole lot of opposing force because it wants to stay in motion. It doesn't want to come to a stop. And so then what we can say is UK is less than US. Okay. What does that look like? Let's look at an example. A team of 10 dogs is pulling a sled at a constant velocity. There's something key. A constant velocity of 8.1 kilometers per hour over the frozen tundra. The dog sled has a total mass of 1,000 kilograms. Calculate the coefficient. So this is what we're looking for. It says calculate the coefficient of kinetic friction between the dog sled and the snow if the dogs must exert a total force of 922 newtons to keep the dog sled traveling at a constant velocity. So what does this key word of constant velocity mean? We've seen it here, we see it there. Constant velocity means that there is balanced forces. If there's balanced forces, that means that force net is equal to 0. Okay? Let's draw a picture. Because we're the ones drawing the picture, we're going to set the direction of motion to the right. Here's our dog sled track. Here's our dog sled. Now, if the dogs and the snow, if the dogs must exert a total force of 922 newtons to keep the dog sled traveling. So we're going to have a force applied of 922 newtons. We always know that there's an opposing force, and we call that the force of friction. Now, this dog sled, it's not levitating, and it's not going through the track, so force normal and force gravity need to be equal to each other because they have to be in balance. And then some pieces of information. We know that velocity is 8.1 kilometers per hour. We know that there's a mass of 1,000 kilograms. It's asking us to find the coefficient of kinetic friction. And we know that force applied is going to be equal to 922 newtons. So it's asking us to find force, the coefficient of kinetic. So force normal is going to be equal to, actually, let's do it this way. Force of friction is equal to the coefficient of kinetic friction times force normal. When I go back to my list, that's what I'm looking for. Do I see in this list that I have force of friction? Nope. I'm going to have to solve for it. Do I see in this list that I have force normal? Nope, I'm going to have to solve for it. Let's look at force normal. We know that this box or this dog sled, it's not levitating and it's not being driven through the ground. Therefore, force normal has to be equal to force of gravity. And we see that here. Force net is equal to force normal plus the negative force of gravity. It's balanced, so that force net is 0, the force net in the y, which means that force normal, if I want to bring this over, I have to add force of gravity. So I have a positive Fg. Fg we can solve, because it's not in this list, by going mass times acceleration due to gravity. So 1,000 kilograms multiplied by 9.81 meters per second squared, because over here g is an unwritten value. And we're going to get 9,810 newtons for force normal. Over here for force of friction, again, force net in the x is equal to force applied plus the negative force of friction. We're looking for this force of friction, so let's make it positive. So we're going to have force of friction is going to be equal to force applied. Let's move this one over. Minus force net in the x. But what we see is that it's at a constant velocity. So again, it's a balanced force, so that's 0. Which means that force applied is equal to force of friction, is equal to force applied. Force applied is 922 newtons, which means that force of friction must be 922 newtons. So now I can go back up and I can solve for this equation here, and I'll bring it over here. Force of friction is equal to kinetic coefficient times force normal. That's what I'm looking for. So force of friction divided by force normal is going to be equal to my kinetic coefficient. I'm going to go 922 newtons divided by 9,810 newtons, and I'm going to get a value of 0.09398 newtons. Okay? When I go back up to the original question, I have 3 significant digits there, and I have 4 significant digits there. I have 2 significant digits there. However, I didn't use that number in my calculation, so I'm going to be limited to these 3. This 8 will have an effect on that 9, and so my answer is going to be 0.940. There are no units because it's a coefficient, and coefficients don't have units. Not only that, when we look at a unit check or do a unit analysis, we see that newtons cross off and leave us with no value. Okay? Let's look at a second example. A 7.6 kilogram object is pulled along a horizontal surface. If the coefficient of friction between the surface is 0.20 What is the magnitude of the force of friction? This word here, magnitude, means that we need a value only. No direction in our answer. But we still have to draw a picture. So direction of motion. And what we see here is a 7.6 kilogram object is pulled along a horizontal surface. So there's a force applied, which means that it's going to have an opposing force, and that will be of friction. And it's asking us if the coefficient of friction between the surfaces is 0.20, what is the magnitude of force of friction? And our mass is 7.6 kilograms. So if I'm looking for magnitude, if I'm looking for magnitude of force of friction, and this is the information that I have, there's two things I need to consider. This one here indicates that I probably am going to use a force of friction is equal to a coefficient of friction times force normal. But what we also need to know is that we aren't going to use a force net equation. Okay? We can't use a force net equation to get force of friction because there's no force applied information. There's not enough information in here to figure that out. So force of friction is equal to U force normal. Now, it's asking us to find this. Do we have the US? Yes, we do. Do we have force normal? Nope. We also didn't complete our free body diagram. And so what we know about this object is that this box is neither levitating nor going through the ground, which means that force of normal must be equal to force of gravity. There's a balanced force at play there. And so how do we solve force of gravity? Mass times acceleration due to gravity. And so we're going to go 7.6 kilograms multiplied by 9.81 meters per second squared. And we are going to get a value of 74.556 newtons, which means that that's what our force of gravity is. Our force of gravity is equal to force normal. So force normal is 74.556. Now that I have these two pieces of information, I can figure out my force of friction. And I'm going to get a value of 14.9122 newtons. When I go back to the question, this is a 2-digit or significant digit value. This one here is also 2 significant digits, but because it's a coefficient, we don't take that value to determine our significant digits. It doesn't determine our level of accuracy. This one here, the 7.6 kilograms, does determine that. And so I'm going to look at only these first two significant digits. The 9 will have an effect on the 4. So then I can say the force of friction is equal to 15 newtons. It asked me for the magnitude, so I do not need a direction, even though force is a vector. And there's my answer. Okay, let's look at a third question. And as you can see, we have multiple steps. This is our base. This is the different pieces we had to go to. This is our base. This is a piece we had to go to. We're ramping up our level of knowledge. An 85 kilogram car traveling at 14.1 meters per second along a level but icy road steps on the brakes. The wheels lock and the tires skid along the icy surface for a distance of 24.6 meters before coming to a stop. Calculate the coefficient of friction between the car's surface and the ice. So first things first, we have to draw a picture. What does this look like? Let's make our direction of motion this way. Here's our object. It's traveling at 14.1 meters per second along a level but icy road. Steps on the brakes. The wheels lock and the tires skid along the icy surface for a distance of 24.6 meters before coming to a stop. Our mass is 895 kilograms, and it's asking us to find the coefficient of friction. Okay, so we have, it's already traveling, so there's no force applied, but there is a force of friction because it's between the car's surface and the ice. The car is neither levitating nor going through the ground, so force normal must be equal to force of gravity. And we need to calculate the coefficient of friction. So how do we solve the coefficient of friction? Right now, this is the only formula we know to solve for the coefficient of friction. Do we have force of friction? Nope. Do we have force normal? Nope. We need to solve for both of those. How do we solve force normal? This is always the easier one. This object is not levitating and it is not going through the ground. So that means force normal, all the forces are balanced. So force normal must be equal to force gravity, right? Force net in the y will be equal to force of normal plus the negative force of gravity. Because it's not levitating or going through the ground, that is 0, which means that Fg is equal to Fn. Okay, this is the formula step that gets us to here. When I look at force of friction, so this is in the y, force net in the x is equal to force applied minus or plus negative force of friction. There is no force applied because it's already in motion. So force net is equal to negative force of friction. Okay, well, how do I find Fg? Because I don't have Fg in this list. Fg is easy. Fg is mass times gravity due to acceleration due to gravity. So this one's going to be 895 kilograms multiplied by 9.81 meters per second squared. And we could write that in our list over here. We could write that there. It's an unspoken value that we know. Force gravity is going to be equal to and then force gravity here we say is equal to force normal, which means that force normal must be equal to 8,779.95 newtons. So we have this Fn. We're looking for this guy right here. Force of friction. Well, we come down here and we say that force net is equal to negative force of friction. How do we solve force net? Well, we know that force net is equal to mass times acceleration. Okay, well, we have mass, but we don't have acceleration. How do we find acceleration using this information here? Well, I have VF, I have VI, and I have D. So that formula must be and we're looking for A. So VF squared minus VI squared over D is equal to A. And all of you that have done these practice questions, do not forget to square your values. (2D). I need to move the 2 over. So my A is going to be equal to 0 squared minus 14.1 squared divided by 2 times 24.6. And my A came to negative 4.04085 ... meters per second squared. Please note this negative sign. Does that negative sign make sense? Absolutely. Because the wheels lock, the vehicle steps on the brakes, the wheels lock, and the tires skid along before coming to a stop. That is deceleration. This is deceleration or acceleration in the opposite direction. Now that I have A, I can figure out force net. So force net is equal to negative 3616.564 newtons. From there, I say that my force net is equal to negative force of friction. So force of friction then must be equal to 3616.564 newtons, right? A negative times a negative is equal to a positive, or actually, I would have force net divided by -1 is equal to force of friction. I just pulled the negative out. Either way, a negative divided by a negative is still a positive. So there's my force net. Now I can go all the way back to my original question and I can solve for US by force of friction is equal to US force normal. US is going to be equal to force of friction divided by force normal. So 3616.564 newtons divided by 8779.95 newtons. So my coefficient should be 0.41191. And there's no units. Newtons cancel out. I go back to the question and I see 1, 2, 3, 1, 2, 3, 1, 2, 3. And because it's all multiplication and division, 1, 2, 3, this 9 will have an influence on that 1. So US is 0.412. The trick to solving these kinds of problems is start with the formula that solves the question. This question is asking us, calculate the coefficient of friction. That's this one here, step 1. Well, when I go and I try to solve it, I see what looks like two unknowns. So I have an unknown that I have to solve for over here, and an unknown that I have to solve for over here. Well, I still don't have FG. I need to solve for that. I don't have force net. I have to solve for that. I don't have acceleration. I have to solve for that. Okay? So this is 4 steps. Actually, it's 6. 1, 2, 3, 4, 5, 6. It's 6 steps to solve this one thing, calculating the coefficient. But when you do it systematically, what do I need to solve for? What's missing? That's missing. That's missing. That's missing. Oh, look, I can solve it. And I can go backwards up the ladder. Over here, I say force of friction, so I got to do force net. I still can't solve for force net, so I have to do mass times acceleration. I can't do acceleration, so I got to do this piece. Once I solve for acceleration, now I can start going back up the ladder, right? I can start acceleration, force net, force of friction. Once I have force of friction and I have my force normal, this is my original question. All I've done is I've just worked backwards up the calculation tree. Okay? Go ahead and give it a try. Page 82, 16 to 18, 21, 23, 24. And I want you to try these practice problems here. An applied force and a loaded dog sled. Give those a whirl.